In October 1981, a Soviet submarine ran aground deep inside a restricted Swedish military zone near Karlskrona. The situation escalated quickly. Heavily armed Soviet rescue ships massed just outside the territorial border, loitering anonymously as they waited for a chance to extract their stranded crew. Sweden responded by deploying its heaviest surface combatants to form a hard blockade. Leading the line were the Halland-class destroyers, projecting Swedish sovereignty in the face of the encroaching Soviet fleet. The Soviet ships eventually withdrew. It was a massive operational success, proving the deterrent value of these heavy warships at the height of the Cold War. Sweden maintained a public profile on neutrality during the Cold War while privately constructing a fleet of aggressive, highly automated warships. The driver for this buildup was the Baltic Sea, a cluttered, geographically trapped environment shared directly with the Soviet Union. In the open ocean, fleets have hours to respond to threats. Here the physical distances between Sweden and Soviet bases were so short that the tactical reaction window collapsed to just a few minutes. World War II-era patrol boats and human reaction speeds could no longer survive in an environment where an attack could originate from just over the horizon. This unique geography forced Sweden to prioritize raw reaction speed and technological automation over endurance of traditional deep-water fleet. Throughout the 1940s, Swedish destroyers evolved through its constant iteration, growing from the light mode class to the larger Visby and Öland classes. This era of brute force engineering reached its peak during the 1950s with the Halland-class. It was the most heavily armed destroyer in Swedish history, featuring a rugged steel superstructure designed to survive the rigors of high-intensity combat. The Halland utilized 58,000 horsepower steam turbines to maintain high speeds while carrying some of the world's first shipborne anti-ship missiles. The Halland-class represented the absolute limit of analog naval power. It was the physical brawn required to hold the line against the Soviet fleet. The crown jewel of the Halland-class arsenal was the Bofors 120mm naval automatic gun L-50. This gun utilized an extreme mechanical layout. Dual ammunition hoists and flick rammers allowed the twin barrels to fire continuously, cycling rounds faster than any previous system of this caliber. A single turret could produce a staggering 84 high-explosive rounds every minute. However, this mechanical speed hit a cognitive wall. A human operator cannot calculate the complex trigonometry needed to track a supersonic target while a gun fires 1.4 times every second. Mechanical hardware had outpaced the speed of human thought. Without a way to compute math faster than the gun could fire, the world's deadliest artillery was becoming tactically obsolete. Saab engineers addressed this bottleneck by moving the aiming process into a digital environment, the 9LV Combat Management System. Established in the late 60s as a specialized air defense director, LV stands for Luftvärn, Swedish for air defense. The 9LV automated the observe, orient, decide tactical loop. Processing radar and sensor data autonomously eliminated the delays inherent in human decision-making. Software evolution accelerated through the 1980s, moving from the fixed program analog computers to the MK1 to the Ethernet-based ad program architecture of the MK3. This modern interface fuses sensor data to evaluate the threats and assign weapons instantly. It allows the system to visually and autonomously categorize targets in the middle of a cluttered sea. The 9LV moved the warship's center of gravity from mechanical gun deck to the digital server rack. If a ship's software can identify and intercept threats fast enough to avoid them entirely, the need for heavy steel armor disappears. This philosophy led to the modern Visby-class corvette. Its faceted carbon fiber hull is designed specifically for stealth, representing a total departure from traditional destroyer design. The Visby operates as a floating computer peripheral. Its stealth characteristics and survival depend entirely on open architecture 9LV managing the battlespace. This open architecture allows for global integration. The system now manages data links, unmanned drones and allied assets for navies in Australia, Canada and Norway. In an age where software wins wars, how long before the warship itself becomes obsolete?